Full moon, half moon, total eclipse. My moon phase lamp is the follow-up to the sunrise lamp I created to convince my son that the day does not start at 5 AM. With this new model, I wanted to make some improvements and break out of my coding comfort zone, as I know I've picked up some quirky hack-it-together programming habits. I also wanted to discover more about the limits of the Pi when it comes to powering NeoPixel LEDs. The moon lamp is similar in design to my son. It is a snapology origami sphere, has a NeoPixel ring for a light, and is driven by a Raspberry Pi Zero. It also has the same variety of light programs, including a gentle sunrise for the morning, and a drifting off program which dips from blue and settles at a low level as a night light. Once again, the spherical shape comes from dividing the 20 triangular faces of an icosahedron into smaller triangles, in this case 25 of them. There are 500 triangles in total in the moon compared to 320 in the sun. I was aiming for the same overall size as the sunrise lamp, so I made the moon triangles slightly smaller. I guess you could say this lamp has a higher resolution. I go into more detail about snapology in my sunrise lamp video, so check it out if you want to know more about this form of origami and to see further examples. In short though, rectangles are folded to create polygons which in turn are snapped together using paper connectors. No glue or other adhesives required. When it came to programming the first lamp, my learning was stunted by the fact that everything worked first time. I followed Adafruit's installation guide and MicroPython tutorials expecting to run into problems, but just didn't. Nothing blew up when I ignored Adafruit's plea to place a capacitor between the positive and negative terminal. Nothing faded due to insufficient power. The RGB values were not reversed, so I didn't need to wrench through the sample code. Red was red, green was green, blue was blue. My lucky stab at coding it using my usual web-based IDE didn't fail, and my first adventure in Crontab succeeded. Everything went well. Bummer. My first learning barrier concerned powering the NeoPixels from the Pi. Just about every other application I came across used a separate power supply. I found several useful videos showing whacking great power supplies which had to be hidden in cupboards, but it seemed rare to find projects where the NeoPixels were powered directly from the 5V pin on the Pi. Amongst other very precise technical information on the Pi Hut website was the general cautionary note to only power a few NeoPixels through the Raspberry Pi. But how many is a few? And what happens at the point you add NeoPixels beyond that mystery limit? Is a gradual dimming the only consequence? Or is the result more exciting, like a Raspberry Pi explosion? My knowledge and understanding of electricity is still very much based on what I learnt at school. There's a triangle to show the relationship between all the elements needed. So we need fuel, heat and oxygen, and to find the electrical current we divide fuel by oxygen, and the more fire the wider the river and the greater the pressure of the electrons. Is that right? It isn't, is it? I dug a bit deeper. From Raspy.tv I learned that the Raspberry Pi Zero would draw around 300 milliamps at most, and Kevin's helpful video demonstrated a good process for following schematics to find information about current draw limits. Most models of Raspberry Pi have a polyfuse which will blow at around 2.5 amps. However, any such fuse is absent from the Pi Zero, and so the 5V pin is connected directly to the power source. No fuse? Well, in my head then, why not connect the aforementioned whacking great power supply directly to the Pi? I was still not entirely sure why this would be a problem, but in trying to find out what the best interpretation of a few NeoPixels would be, my query on Stack Overflow returned 2 pearls of wisdom. Why are you even thinking of using the Pi as a power supply? The Raspberry Pi will act as an expensive fuse. And the Pi Zero has a direct connection between the power and the headers. If you overload it sufficiently, you will burn out the board tracks. So, it's about heat then. And not wanting my paper moon to turn into a flaming meteorite, I thought I ought to maintain a margin of safety. So I decided a few could mean 16 NeoPixel LEDs, but not 24 or 60. I managed to solder and connect the NeoPixel ring with improved precision, but also managed to burn a hole in our vinyl tablecloth too. Adafruit's Uber guide suggests that each NeoPixel requires a maximum of 60 mA, so my ring of 16 should draw a total of 960 mA, or just under 1 amp. This theoretical figure was close to the reading I got from a USB power meter. My next learning barrier concerned controlling the lamp without big delays between a program being selected and it running. The controls for my sunrise lamp are contained in a form hidden on my personal website. When a program is selected, a PHP file writes its name into a JSON file. A Python script checks this JSON file once a minute through crontab on the Raspberry Pi to see if a request to change the light program has been made. It works, but it's not ideal. It's like having my toaster repeatedly ask me if I want toast until I say yes. If I want toast, I'll let my toaster know. With the Arduino projects I'd seen, there seemed to be numerous off-the-shelf options you could download and just get cracking straight away, but I wanted to stay with the Raspberry Pi for now. I knew a web server would be needed and wondered whether LightTTPD, LightTTPD, this would serve the purpose, as it's apparently used to control those epic Halloween light displays. I began following this tutorial for installing LightTTPD with PHP and Python, but it wasn't long before I came across an old foe, file permissions. The install failed, but as failures go, it was fairly silent, and it wasn't until I gave up and switched to an Apache install that I was forced to accept that I needed to get my head around chmod. So, having read the dummy's guide to file permissions, I stuck with the Apache setup and was soon connecting directly to the lamp. The next challenge was running the Python script from the browser. I was expecting this to be far more complicated and that I might need to get my head around some whole new framework like Flask. However, it was achievable with just one line in PHP. The only sticking point was due to many of my lights programs running within a while true loop, resulting in the web page seemingly never finishing to load after a button press. However, I soon learnt that the script could run in the background by passing in some arguments. I was also forced to address the feedback I'd received about my clunky use of wget to transfer files from my personal website to the Pi in my previous project. I read through the secure copy page on the Raspberry Pi website and then slipped into a far better process of editing my code with Sublime on my Pixelbook, then using SCP to transfer to the Pi. I don't know how much of a hack this all is and whether I need to properly explore Flask or similar as a next step, but in terms of running a simple Python file from a browser, my process worked fine. I noticed from this tutorial that with Flask the LED comes on almost instantly, but with my approach there is a short but very tolerable delay. I suspect this delay is to do with the fact that my program starts by killing existing Python processes. I was hoping that the moon phases would display in a more striking fashion using this simple divider, but so much light was bounced around, even during a crescent, that the effect was essentially lost. However, it was still a useful learning process to go through. For the moon phase information, I came across Visual Crossing, which is a service which provides all kinds of APIs for weather and astronomical information, and having signed up for a free account, I was able to make use of their moon phase numbering system. The API returns a JSON file, and a Python script on the Pi extracts the moon phase value and uses this to turn on the appropriate LEDs. This is definitely a service I will return to in the future, as it was certainly easy to use. As far as snapology origami goes, I'm not convinced having smaller but more numerous triangles made for a better lamp. It struggles to keep its spherical shape. Otherwise though, it works well as a morning lamp and as a night light. Thank you for watching to the end. I hope you've enjoyed this video. In the description are links to the full videos for each of the clips I've used, so you might want to go check those out. Also, I intend to keep on putting on videos that show my learning and my next projects, so if that is of interest to you, then please consider subscribing.